The year 2024 marked the 100th anniversary of Edwin Hubble publishing his discovery that the Milky Way is not the entirety of the known universe. In that year, he discovered, by looking at our nearest neighbor, large red-blooded galaxy, the Andromeda Galaxy. By the way, it wasn't known as a galaxy back then because back then they were just fuzzy things in the night sky. There were irregular nebulae, there were spherical nebulae, there were spiral nebulae. Nebulae is just fuzz in Latin. Okay, so the Andromeda Nebula. He's looking at it, but I wonder how far away that is. And so he found a star in the galaxy with the world's largest telescope. He couldn't do this with other telescopes at the time. This is the Carnegie Observatory 100-inch Mount Wilson telescope, 100 inches in diameter, the most powerful telescope in the world on a mountaintop. He identifies a star, a variable star, a star that varies in brightness in the Andromeda Nebula. Says, wait a minute, that star is like these other stars that are nearby, that are right here close to us, but it's so much dimmer. How could it be that dim if it's in our own galaxy? It's varying in exactly the same way as these other stars are that are right here in front of my nose. So you run the math on this, and if it's the same star, and if it's in the Andromeda Nebula, it puts the Andromeda Nebula far outside of the Milky Way. Oh my gosh! Outside of the Milky Way, an entire system of stars? In that moment, our knowledge of the universe grew from this provincial Milky Way to the Milky Way being just one of countless other galaxies. And overnight, the Andromeda Nebula became the Andromeda Galaxy. We were off to the races. How about all these other spiral nebulas? Let's get distances to those. And you keep doing this. And by the way, it wasn't just 1924. That entire decade, the entire decade of the 1920s, was ripe with all manner of discoveries, not only in astronomy, but in physics. By 1929, enough of these galaxies had been collected, and we found out that they're actually moving away from us. The universe, which is comprised of these galaxies, is expanding. So within the same decade, between 1924 and 1929, Edwin Hubble publishes papers showing not only are we not alone in the universe, alone as a galaxy, but that the entire universe is expanding. If you wanted to know why we named the space telescope after that man, that's why. By the way, those two discoveries, that our galaxy is not alone in the universe and that the universe is expanding, was easily worth a Nobel Prize each for him. For Edwin Hubble. But at the time, astrophysicists were not in the running for the Physics Nobel Prize.
And there isn't a Nobel Prize for just astrophysics. So we wouldn't start getting Nobel Prizes until much, much later. And now we earn the meta rate of 1 or 2 per decade. Meanwhile, in physics, we're discovering the basic tenets of the quantum. Quantum mechanics, which I will more commonly called quantum physics, was shaped and developed in the 1920s, understanding the behavior of molecules and atoms and electrons and nuclei. If you were someone back then seeing a physicist probe the atom, what might you be saying? You'd say, why are you wasting money on that, or your time? This will never be worth anything. What's going on? Yeah, it would take some decades, at least 3 or 4 decades, before we would realize the importance and the value of exploiting our knowledge of the quantum for the very foundations of the information technology revolution. There is no creation, storage, or retrieval of digital knowledge, digital information, without an exploitation of the quantum. These are the electronic circuit components. All of this come from our understanding of how matter behaves on its smallest scales. So as we go through the 2020s, just pause for a moment and reflect on the fact that our awareness of the universe grew exponentially 100 years ago with a brilliant person working on the world's largest telescope and a whole team boatload of physicists, multiple Nobel Prizes given to each of the components, each of the discoveries that together make this branch of physics called quantum mechanics. that was going on, and no one had any clue how big a part of our future economy and existence that would become? You know what the greatest invention of the 20th century was? It wasn't the airplane. No. It wasn't the car. It wasn't space travel. It wasn't any of that. It was computers. You lived barely a moment of any day without access or dependence on computers, and computers depend on quantum physics. So those of you who fear science or don't like science or think science doesn't amount to much, move back to the 19-teens. How about that? And come back and then tell me about it and see what you think of it. There's no time that I would rather live than the present. And in fact, send me to the future. I want to see what current discoveries will bring that next generation. Think about it. If you have access to the most powerful telescope in the world, that's right for all manner of discovery, not only of learning more things about objects you already knew something about, it'll discover objects you knew nothing about. Once you exhaust what a 100-inch telescope might bring you, time to make a bigger telescope. So in the era that followed, in the generation that followed this 100-inch telescope, we built a 200-inch telescope.
This was the famous one on Mount Palomar, controlled by the California Institute of Technology. That telescope, 200 inches. If you do the math, yes, that number is the measure of the diameter, but the power of the telescope comes not only from how wide it is, but from the area, the collecting area. And that goes as the square of the diameter. So a 200-inch telescope has 4 times the collecting power than a 100-inch telescope does. When you do that, you're going to see things that are dimmer out in space that you didn't even know was there. You didn't even know to ask the question about whether it would be there because you don't know what you don't know. Fast forward a generation after Palomar, you get to the Keck telescopes. The Keck telescope, now you're talking 400 inches, 10 meters in diameter. It's 4 times more powerful than even that. In astrophysics and the gathering of data on the universe, bigger is better. And you can add to that a tandem advance in detectors. Back in Hubble's day, he's using photographic plates. Back then in astronomy, they'd be made of glass. Later, they'd be put on plastic film. Those were on glass. You'd expose it, then you'd develop it, wait for it to come back, then you'd analyze it. And photographic emotions are not very sensitive to light. They're just not. But you know what is sensitive to light? Digital detectors. My people were early out of the box in valuing CCD detectors, charged coupled devices, that's what that's called, where light triggers a response in the electrons of the detector. And then you count electrons instead of measuring photons. So when you do that, it's way more efficient and way more effective. So combine the bigger telescopes with way more sensitive detection instruments. And you know this thing about twinkling stars? Don't ever wish twinkling stars upon an astronomer. A twinkling star is starlight that would otherwise come through the atmosphere in a stable way, but different thermal layers. The whole atmosphere is not at the same temperature, and it's not perfectly layered, so the light refracts back and forth, and it goes from one density of air pocket to another. And then the light buzzes and jiggles. So if you want to see precise things in the universe, you got to get above the atmosphere. The Hubble telescope, one of the great telescopes, put above the atmosphere so you don't get the jiggling of light.
Meanwhile, back on Earth, the military figured out how to stabilize the image of a star, even though it's going through these pockets of different temperature air. That image stabilization has transformed modern astrophysics and the telescopes that are doing the hunting. So big telescopes, image stabilization, sensitive detectors, we just took off. And no longer are we trying to understand the distance to the nearest fuzzy nebula as Hubble did. Now, 100 years later, we're characterizing the properties of galaxies being born in the early universe with the likes of the James Webb Space Telescope. By the way, who is James Webb? He was head of NASA while we were going to the moon, in case you were wondering. I love celebrating how far we've come in my field and in civilization and science and technology. We're about an exponential growth curve ever since it all began. An interesting fact that when you're on an exponential growth curve, wherever you pause and look back, it feels like you're living in special times. Feels like it. So Right now, we have an SUV-sized rover on Mars that brought a helicopter with it. We're flying close to the sun. We flew past Pluto. We're on the heels of quantum computing. AI is ready to transform our world. We say, wow, we're living in special times. Well, what were people saying 30 years ago? Wow, the internet, the whole world is a library. We have an email account. Wow, I can talk to anybody. People were celebrating whatever the advances were, comparing that to 10 years earlier when nobody then had it. It is the hallmark of an exponential growth curve where everybody on it, at any cut you take through it, thinks they live in special time. I won't even begin to imagine what 10 years from now, not even 50 years, not even 30, I'm not even going to begin to imagine, because I'll get the wrong answer for sure. But my hope is that we maintain the exponential growth so that in 30 years, 50 years, 100 years hence, they will look charmingly back on the years of the 2020s and say, all they knew. Oh, how charming. Oh, they thought there was a multiverse. That's cute. Oh, they didn't know how to time travel back. They didn't know about life on other planets. Oh, could be. But when people ask, what questions today would you like most seen answered? And the answer I give is that's the wrong question for me. I want to know what questions I do not yet know to ask that will arise up from discoveries we have yet to make. I lay awake at night wondering what those questions are.